Let's take a look at how we reduce a fraction such as 18 over 30. To reduce fractions to simplest form, we need to find a number that the top and bottom part are both divisible by. In this case, 18 and 30 are both divisible by 6. 18 is 3 times 6. 30 is 5 times 6. To reduce the fraction, we divide both the top and the bottom by the common factor of 6. And this leaves us with 3/5 for our answer. We're going to do something very similar when we're reducing rational expressions with polynomials on the top and bottom of our fraction. We're going to start by factoring the numerator and denominator as much as possible, and then we're going to cancel out any common factors. For example, suppose we have 2x plus 6 over x squared minus 9. When we factor the numerator of this problem, we can factor out a greatest common factor of 2, and we have 2 times x plus 3. Factoring the denominator, that's a difference of squares. We would have x plus 3 times x minus 3. Notice now we have a common factor in the numerator and denominator of x plus 3. We can cancel those out. And this leaves us with 2 over x minus 3 for our simplified expression. If we're trying to simplify our next fraction, we start by factoring. In the numerator, you can factor out a greatest common factor of 2. And we would have 2 times x squared minus 3x minus 10. In the denominator, we could also factor out a greatest common factor of 2. We would have 2 times x squared minus 25. Now on the top, to factor x squared minus 3x minus 10, we would have an x at the beginning of each group. To multiply to be a negative 10 but add up to a negative 3, we would need a minus 5 and a plus 2. On the bottom of our fraction, we have a difference of squares. The square root of x squared is x. The square root of 25 is 5. We put a plus in one group, a minus in the other group. And now looking at this, we can see we've got a couple of common factors. We have x minus 5 and x minus 5 on the top and the bottom. We also have 2 and 2 on the top and the bottom. So the simplified form of this fraction would be x plus 2 over x plus 5. If you would like to try the next two problems on your own, pause the video now and resume when you're ready to see the solution. The factoring for the next few problems can be a little bit more complex, but let's take a look through it a little bit at a time. On the numerator of our next example, we can start by factoring out a greatest common factor of x. In fact, I'm going to work with the numerator and denominator on this one separately because they're both a little bit long. So we'll have x times, and then we would be left with x squared minus 5x plus 6. The x would still be out at the front, and to multiply to be a positive 6, but add up to a minus 5, we would have a minus 3 and a minus 2. Now let's think about the denominator. With 4 terms in the denominator, we need to do what we call factoring by grouping. The first 2 terms, x to the third minus 2x squared, we could factor out an x squared. And we would have x squared times x minus 2. When your second group starts with a negative, you factor out a negative. Here we would factor out a minus 9. Negative 9x, when we factor out negative 9, we're left with x. 18 divided by negative 9 is minus 2. we have an x minus 2 in both parts, which we can pull to the front. Left over from the first portion, we have x squared. Left over from the second portion, we have minus 9. Now in this case, we can keep going. The x minus 2 is still there. X squared minus 9 we can factor as a difference of squares. We put x at the beginning of each group. The square root of 9 is 3. That goes at the end of each group. We put a plus in one group and a minus in the other. So now if we put this all together, the numerator is x times x minus 3 times x minus 2. In the denominator, we have x minus 2 times x plus 3 times x minus 3. We can see then that we have a common factor of x minus 3 on the top and the bottom. We have a common factor of x minus 2 on the top and the bottom. When we cancel those out, we're left with x in the numerator and x plus 3 in our denominator. Looking at our next problem, x squared minus x minus 12 in the numerator, to multiply to be a negative 12, but add up to a negative 1, we would have x minus 4 times x plus 3. Now 4 minus x in the denominator we can't factor. So I'll put parentheses around it to remind myself I have to treat it as a group and either cancel out the whole thing or nothing. X minus 4 and 4 minus x are not exactly the same, but they are opposites. With subtraction, when you change the order, they are opposites of each other. And you can cancel out opposites, but because we're not canceling out the same thing, we're canceling out opposites. When you do that, you need to put a negative sign in front of your result. So here, the negative of x plus 3 would be the answer. And if we want to, we can distribute the negative sign and see that it would be negative x minus 3 for the result. If you would like to try the next two problems on your own, pause the video now and resume when you're ready to see the solution. For 9 minus x over x squared minus 81, there's really nothing we can do to factor the top part. So we'll leave it as 9 minus x. In the denominator, x squared minus 81, we have a difference of squares. It would be x plus 9 times x minus 9. This is another situation where we have those subtraction opposites. 9 minus x and x minus 9 are opposites of each other. We canceled out opposites, so we need to put a negative sign out in front. Also, since we canceled out everything from the numerator, we would have a 1 still left up there. And our solution is negative 1 over x plus 9. Looking at our last problem, factoring x squared minus 49, we have a difference of squares. We would have x plus 7 times x minus 7. In the denominator, the first thing we can do is factor out a greatest common factor of 2x. We would be left with 2x times x squared minus 4x minus 21. So we'll have a 2x in the front, and factoring that trinomial to multiply to be negative 21 and add up to negative 4, we would need x minus 7 times x plus 3. And looking at what we have here, we can see we have a common factor in the numerator and denominator of x minus 7. So we cancel those out, and we're left with x plus 7 over 2x times x plus 3.